I have a question for everyone. What do you see when you look at this image? Do you see fire, smoke, air pollution? Pretty bad, right? But what about that firefighter spraying huge quantities of that firefighting foam? The military uses hundreds of thousands of gallons of this foam each year for its training activities. Unfortunately, that foam is rich in certain compounds known as PFAS, or per and polyfluoroalkyl substances. I'm pretty sure everyone here in this room has either heard of or is familiar with the term PFAS. These compounds are known as forever chemicals because they do not degrade easily in the environment. And since they are used in a variety of everyday and daily use products, I'm pretty sure everyone here, including myself, have been exposed to some levels of PFAS. Now, what happens when you spray some of that firefighting foam on the concrete pad? Some of these compounds evaporate, some of them get washed away, while a small portion may seep into the concrete. But what happens when you do this every day for not one, not two, but say 30 years? After 30 years, we have a lot of these compounds trapped inside the concrete. But what happens next? What happens to these compounds? Do they migrate? Do they stay trapped inside? Do they leach out of this concrete? Or, due to the highly alkaline nature of concrete, do they transform into other compounds? We don't know. As of now, no one knows. But maybe with my experiments, I might solve some of this mystery. I'll show you how. Through my experiments, I'm trying to intentionally contaminate the concrete cores in lab with a mixture of not one, but 3 different firefighting foams. And this exposure will be through 2 different methods. The first one will be a slow movement of these compounds under the action of gravity. And the second one, I'm repeatedly applying a smaller volume on the surface of concrete. I will take regular samples, and at the end I will drill into the concrete to get the PFAS adsorbed at certain depths. The results of my experiment will give me crucial information about how these compounds might travel and how they might transform and give rise to new compounds which were absent from the initial mixture. This data will be very important for future researchers and industry partners to develop sustainable remediation and mitigation techniques for these hotspots of PFAS contamination. And eventually it might help us transition towards a safer and PFAS-free world for our future generations. Thank you.